What makes gravity the weakest fundamental force? Have you ever wondered why gravity, the force that keeps us grounded, is considered the weakest of the four fundamental forces? It might seem surprising, especially since gravity is the force that governs the motion of planets and stars. Let's break it down in a way that makes sense. First off, gravity's strength is vastly smaller than the other forces when we look at the scale of atoms and particles. For instance, the strong nuclear force, which holds atomic nuclei together, is about 1 trillion times stronger than gravity. This means that at the atomic level, gravity has almost no effect, while the other forces dominate. Now let's talk about how gravity works. Its strength depends on two main factors: mass and distance. The more massive an object, the stronger its gravitational pull. However, when we are dealing with tiny particles like protons, the gravitational force is incredibly small. For example, the electromagnetic force between two protons is about 10 to the power of 36 times stronger than their gravitational attraction. This massive difference in strength is a key reason why gravity is weak at small scales. Another interesting aspect of gravity is that it only attracts, it never repels. This is different from electromagnetic forces, which can cancel each other out. In gravity, all mass attracts, which means that the force always adds up. However, this universal attraction does not make it stronger at small scales. The gravitational constant, which determines the strength of gravity, is extremely tiny compared to the constants that govern the other forces. Gravity does have an infinite range, similar to electromagnetism, but its strength diminishes significantly over distance. The strong and weak nuclear forces operate only over very short distances, making them strong but limited. In contrast, gravity's weakness at small scales is balanced by its ability to act over vast distances, which is why it plays such a significant role in the structure of the universe. To illustrate gravity's weakness further, we can look at the concept of Planck force. This theoretical measure represents the strongest possible force in nature. Gravity's actual force is many orders of magnitude smaller than this, which mathematically explains its relative weakness compared to the forces that govern particles. In our everyday lives, we often do not notice gravity's weakness because large objects, like planets, have enormous masses. Their gravitational pull becomes very noticeable, which is why we feel gravity pulling us down to the ground. Even though it is the weakest force in fundamental physics, it is still the force that shapes our universe on a grand scale. In summary, gravity is the weakest fundamental force because its intrinsic strength is far smaller than that of the other forces, especially at the atomic level. Its dependence on mass and distance, the tiny gravitational constant, and its always attractive nature combine to make it weak yet long-ranged. This contrast between its weakness and its cosmic importance is a fascinating aspect of physics that continues to spark curiosity and research.